So we're going to take the derivative of the following function, where k is just some arbitrary constant. And I think the easiest way to approach this one is, before I take my derivative, I'm going to rewrite this as k times x to the minus 1 plus k times x squared plus 1 to the minus 1 minus e to the kx plus x to the k. Now we can take the derivative, and I think it's easier because I got a couple of power rules here. So first thing, I'm going to name it, I'll call it g prime of x. And the derivative here, like I said, is just a power rule. Bring the power down, so I get negative k x to the minus 2, and that one is done. This one will involve a chain rule because I've got an inside function here of x squared plus 1. So I'm going to bring the negative down, and that's going to give me a minus k. I'm going to leave the inside alone, x squared plus 1. Decrease the exponent by 1, that becomes a negative 2. Now times the derivative of the inside, so times 2x. So that's all the derivative of this piece here. Here I have an exponential, and exponentials always have themselves in this, but because the exponent is more than just x, in fact it's k times x, it is going to be a chain rule. So I'm going to have minus, like I said, it's going to have itself in there, e to the kx times the derivative of the exponent. The derivative of k times x is just k, because this is basically a linear function. Derivative of a linear function is just the slope. The next function, which may be a little difficult to read, is x to the k. That's a power function, so this is a power rule. Bring the power down and decrease the power by 1. So here's our derivative. This is a fine answer for the gateway. If you wanted to, you could rewrite this with positive exponents, so negative k over x squared minus 2kx, we're putting the k and the 2x on top, over x squared plus 1 squared minus k e to the kx plus kx to the k minus 1. That's not a necessary step for the gateway, but if you wanted to rewrite it with positive exponents, that's what we would do.